All right, this is chapter 4. We're only doing a little piece of chapter 4. Again, this will be on your quiz, but not on your test. So just make sure you're studying this. I already posted the study guide for chapter 5, 1 through 3. But you'll see some transformations on your quiz. Keep in mind your quiz is next Friday the 18th. So you guys have a whole week, okay? All right, rigid and non-rigid transformations. So transformations, there are 4 types of transformations: reflection, rotation, translation, and dilation. We are not doing dilation. That is a non-rigid motion, meaning the size of it is changing. So right now we're only focused on the rigid motions, which is my reflection, translation, and rotation. You're going from one image to a new image. So how can you determine what my new image is? I'm going to kind of draw a figure to show you how you can tell. So normally your first image obviously will be labeled. Here's ABC. This is called my pre-image. And your new image is called your image. So ABC. How can I tell the difference? You will normally see it with a little apostrophe at the top, okay? So that little apostrophe is telling you this is my new image. So I'm going from my original image, which is my pre-image, to my image, which is my new image. And again, you have to look for those apostrophes. If you are not looking for those apostrophes, you could get the rule for solving them completely wrong. So definitely look at it first and then go ahead and find what you need to. So again, like I said before, the difference between rigid and non-rigid is rigid motion does not change the size of your shape. However, non-rigid motion changes the size and dimension of the shape. Okay, so rigid again does not. However, non-rigid does. All right, these are my rigid motion. Again, my shape size is not changing, but the location on my graph is. So translation is a slide. Reflection is a reflection. Okay, that one should be pretty easy. And a rotation is being rotated. So we're going to go ahead and do translation first. Translation is, like I said, it is a slide. Whether it's moving to the left, to the right, or up and down, or both, you're going to have to figure out the rules. So rules for translation is you're taking the value of your original x, and then you're adding or subtracting it by the amount of times you moved, and same thing with your y. You're adding it or subtracting it by the amount of times you moved. So we're just going to go ahead and do this as an example. Looking at this graph, I'm starting with my pre-image, which is the one in blue. So writing down the coordinates, A is 3 or 0, 3. B is 2, 4. C is going to be 1, 0. Okay, so that is my first coordinates of my first one. Now, how am I determining my movement? My x values. So my x values is 0, 2, 1. I'm either adding it or subtracting it by the amount of times I moved on the x. So here is my first A, here is my second A. These are my x values, the ones going up and down. So I'm going to count how many times did I move. Okay, how many times did I move? So I moved 1, 2, 3, 4, 5. If I'm moving to the right 5 times, do you think I'm adding or subtracting? Any ideas? If you're moving to the right, are you adding or subtracting? Good, I'm going to add. So I'm adding 5 to all of them because it's the same type of slide. Now I'm going to go ahead and find the rule for my y value. My y values, I have 3, 4, and 0. And now that has to do with moving up and down. So I already moved 5 times to the right. I'm moving down once. Do you think I'm adding or subtracting? Good, I'm going to subtract 1 from each. If I did my translation correctly, then that means my coordinates for my image, meaning the one with the apostrophe, my new image, should be correct. So if I'm solving it, what's 0 plus 5? 5. 3 minus 1 is going to give me 2. Doing my next one, B. 5 plus 2 is going to give me 7. 4 minus 1 is going to give me 3. And the last one, 5 plus 1 gives me 6. 0 minus 1 is negative 1. Do I have the same coordinates? Yes, so that means this is my rule. X plus 5, Y minus 1. That's my rule. So my rule for this one, okay, I'm starting at X and Y. My rule would be X plus 5, Y minus 1. Okay, translations are pretty easy. Again, it's just a slide on your graph. All right, looking at the next one, we have a reflection. Okay, reflection is like a mirror image. Like I said before, if you're putting paint on half a paper, you fold it in half, and it's onto another paper, it made a reflection. That folding part where I'm folding it, that's called my line of reflection. So line of reflection is right here in green. So I'll highlight this in green. That's my line of reflection. And that is, for this diagram, my line of reflection is where y equals 1. Okay, so again, my line of reflection for my diagram is where y equals 1. Okay, to find new points, count the same distance away from the line of reflection. So looking at this diagram, if they gave me my image, which was up here, and they say make a reflection, my reflection is where y is 1. If I were to count 1, 2, it's 2 points away right here. This should also be 2 points away. My C is right here, and my B should be 1 point, same as the other. So you're kind of meeting at that line of reflection. You're reflecting it from where it is. So this one's pretty easy. You could really just count for these. However, here are 4 that always use this rule. This is a rule that should be remembered. So when you have your X and Y and it's reflected on the X axis, all you're doing is changing the sign of your Y. They put B, but still we could follow along. Looking at the next one, if it's reflecting on the Y axis, you're just changing the sign of your A or your X. If it's reflecting where Y is X, you're switching them. If it's reflecting where Y is negative X, you're switching them and changing the sign. So just be aware of those rules. And the last one is rotation. Looking at a rotation, it's a fixed point. It turns at a fixed point, and there is normally the center of the rotation. It's fixed at the center. It's mainly at 0. I think we're just focusing on 0. I don't think we're going to move it anywhere else. But looking at this diagram is moving counterclockwise. And if we already know our coordinates or coordinate plane has a total of 4 quadrants. Each quadrant is 90 degrees, so pay attention to how this is moving. It's starting here. Here's my blue. It's starting here. If it were to move over here, this is considered a 90-degree rotation. If it were to rotate over here, this is a 180-degree rotation. And because it's moving over here to this quadrant, this is considered a 270-degree rotation. Okay, so if you need to circle them or figure out where it's going, use that. Okay, 90, 180, 270, keep in mind, it could be in different quadrants where it starts and where it ends. So rules for this. These ones are pretty easy as well. If it's rotating at 90 degrees, you're switching the order and you're changing the sign of your B. If it's rotating at a 180 degree, you're just changing all the signs. And then if it's switching at 270, again, you're changing the order and changing the sign of your A, which is considered your X value. Okay, so this is a lot of rules to remember, but with practice, it'll be really, really easy. All right, looking at these examples, it says identify the translation, write a rule. So we're going to do multiple things. We're going to write a rule, identify it, and find the coordinates, okay, just for practice. So looking at this, can anybody tell me what kind of transformation is this? Yeah. Reflection. Good, this is a reflection. So I'm just going to write reflection. Okay, and it's reflecting where? What is the reflection? Where is it reflecting? Yeah.
Over the y.
Good, this is reflecting on my y-axis. So it's reflecting right here, where this green line is. All right, and looking at that, knowing that, what would my rule be? If you forgot what the rule is, you have x, not y. You have your original image. And then your rule is going to be, you're making the x negative. So looking at this one, I'm going to go ahead and write my first image. Okay, A is going to be -2, -1. B is -1, -1. And C is -2, -5. So knowing the rule, we're going to go ahead and do my D, which is 2, -1. E, which is -1, or just kidding, not -1, +1, -1. And then F is going to be 2, -5. Okay, so we're just finding the coordinates using the rule. Looking at 2, what kind of transformation is this? Yeah.
Translation.
Good, this is a translation. And the rule for this is we're going to have to count. X, Y. All right, counting. Oops. Let's see what we have. All right, what you're going to count is you're going to start from the L. And for your X, you're going to count left and right. So you're going to go 1, 2, 3, 4, 5. So because I'm going to the left, it's going to be X -5. And then my Y, I'm going to count 1, 2. I'm going up, so it's +2. And that's my rule for this transformation. All right, finding the coordinates. First, I'm going to go ahead and do my pre-image. So I'm actually going to do it right here. My M, coordinates for M is 4, 1. Coordinates for N, I have 5, -1. And then L, I'm going to have 1, -1. So following the rule, we're just going to subtract from our X's. So just writing it, don't forget those apostrophes. I'm going to have -1, comma, 3. And then for my N, I'm going to have 0, 1. And L, -4, 1. So if you check it and look at the graph, then you should see that they line up. All right, going to the next one. This is a rotation. All right, finding my degree of rotation. If you're looking at it, this is where my pre-image is. Okay, so for this one, I'm starting here. This is 90 degrees. This is 180. And this is going to be 270. So we have to know the rule for 270 degrees. So a 270 degree rotation, you have your X, Y. And then it's going to be Y, -X. So using that rule, we're going to go ahead and write the first coordinates. Using our pre-image, R is 3, 1. S is 5, 1. T is 5, -3. and U is 2, negative 1. So using the rule, all you have to do is switch them and change the sign of your x. So just writing what they would be. Again, don't forget the apostrophe. This would be 1, negative 3. This would be 1, negative 5. This would be negative 3, negative 5. And this would be negative 1, negative 2. Alright, so example number 2, it says graph the triangle with the vertices P, Q, R, and its image after the translation. So for this one, they're already giving us the rule. All we have to do is plug it in. So just taking the coordinates they gave me, I have P, which is negative 2, 3. Q, which is 1, 2. And R, which is 3, negative 1. So using the rule that they gave us, we're going to go ahead and just plug it in. So I have my new P, I'm just adding 4 minus 2 for my Y. Same thing for my Q, following the rule. And R, 7, negative 3. Alright, going to 2, reflection over the x-axis. So for that, you have to remember the rule. If it's reflecting over the x-axis, you're going to keep the same x and y, but you're changing the sign of your y. So using, again, what they gave us P, which is negative 2, 3. Q, which is 1, 2. And R, which is 3, negative 1. And then going ahead and using the rule for reflection over the x-axis, I'm going to get P, which is negative 2, negative 3. The new Q, which is 1, negative 2. And then my new R, which is 3, 1. And then again, we have 180 about the origin, so you have to remember the rule. This one's pretty easy. You're just keeping your x and your y where it is, but you're just changing the sign. So again, using what they gave us. P is negative 2, 3. Q is 1, 2. And R, which is 3, negative 1. And all we're doing is changing the sign for both x and y. So P is going to be 2, negative 3. Q is going to be negative 1, negative 2. And then R is going to be negative 3, 1. Alright, these graphs, you're going to use what you got for the previous examples. So I am going to graph them. You guys should have it on your page if you copied it down from the last slide. So I'm just going to use the coordinates because I have them written down, and I'm just going to graph them, or I'll just go ahead and write them down. This one is a, let me make it a little bigger, translation. Okay, and we started with P, Q, and R. Negative 2, 3. 1, 2. 3, negative 1. And then change. Oops. Alright, graphing that. I'm going to have negative 2, 3, which is right here. Please make sure you are labeling. If you're not labeling them, you're going to get them wrong. So definitely label your points. And I need to be able to see that they're labeled. So what's P, what's Q? Your test will not be in color. So I need you guys to make sure that you're labeling them correctly. Using that apostrophe if you have to. 2, 3, 4, 5. Excuse me. Here's my Q. 5, 6, 7, 1, 2, 3. And then here is my new R. So it should look something similar to that. And then looking at number 2, I have a reflection. And my P and my Q is the same. Oops. And then this was -2, 3, or -3. 1, -2, and 3, 1. Graphing them, I have -2, 3. Whoa. Let me fix that. This is P. Q. R. And then using my new coordinates, I'm going to have -2, -3. I'm going to then get 1, -2. And then R is 3, 1. So if you're looking at this one and you're wondering where the reflection is, it's right here. So I can check it by saying if this is 1 point, this should also be 1 point, and this is 2 points. Then this is 1, 2, 3, 1, 2, 3. Right. And the last one was a rotation. So my rotation, -2, 3, 1, 2, 3, -1, and then my new points. Alright, graphing them, -2, 3, which was right here, Q, which is 1, 2, and then we had -3, -1 for R. And then my new points, 2, -3, 1, 2, 3, Q, which is -1, -2, R, which is -3, 1. Alright, and that's it. This will be on your quiz, but not on your test, and your quiz is on the 18th.